Good morning and welcome to the summer workshop series offered by Pentair. Today's topic is one of those things that if you aren't really vested in understanding how backwashing media works, you're probably not tweaking this too much in your setups at this point in time with your customers. Most of the time, this is a topic that even in residential applications doesn't get applied very often. It's more applied to commercial and high purity waters from the standpoint of managing backwash, but it's also something that's going to impact well waters significantly throughout the country, depending on dirt load as well. So backwashing media, and why is it critical to media performance? It's a fundamental thing. Anytime we put anything in a tank and run water through it, that media in that tank is going to act as a filter, no matter the purpose of that media. So we're going to talk about critical points of installation, what really happens during a backwash, bed lift and expansion, how long to backwash. Backwash is temperature dependent, which is something that's quite often overlooked. Issues with backwash and solutions, and then finally questions. So during an install, pay close attention to the following things. Proper backwash requires consistent flow and pressure. So if we have an undersized well tank or an improperly pressurized well bladder tank in a residence, this will impact consistent flow and pressure, impacting the quality of backwash. Plumb drain line with a proper air gap. And this is critical to keep that drain line free of biological growth, which can and will limit the backwash flow rate. Besides the obvious potential biological risks to the unit itself, we're just talking about backwashing in this context. That proper air gap prevents critters from growing up inside the drain line and keeps it from being plugged with biofilm and growth. Plumb a drain line to a drain that can handle the flow. If your drain line cannot handle the flow of your softener or your backwashing filter, you're going to have a very dissatisfied customer. Critical to achieving success is making sure you have some place for that water to go. There's a particular quick service restaurant out there that does not recommend water softeners to its franchisees because of this drain line flow issue, because they have grease issues with their drains clogging. So they don't recommend softeners. I've seen some of their locations actually have the softener drain line routed outside to a French drain because of their sanitary sewer issues clogging with grease. So it can be a particular problematic issue in certain facilities. So what's happening during a backwash cycle? Well, we're reversing the flow of service water in the unit. So essentially, during service, water will come down, go through the bed, top of the bed of the resident, back up the center standpipe. But in backwash, what we're doing is we're forcing that flow to go backwards through the unit, down the center standpipe, and up through the media. What this does for us is it causes the bed to lift and allow for a scrubbing action from the turbulent, chaotic motion of the media, whether that's water softening resin or activated carbon, whatever it is, you need to get this bed lift. And bed lift and expansion is predicated upon the media itself. Okay, we'll get into the technical details of that later. But what we're really trying to do is lift this bed up to free up space to allow the dirt load to come up and off the resin or media and go out the waistline. And this is critical to understand because this dirt load coats the media. And if you don't have good contact with the water, the media really cannot react and interact with the water the way we want it to. So dirt load over time impacts capacity and the ability for the media to function. So the backwash flow rate, BFR, and flow control for the media must be set properly to get the proper bed expansion. We'll look at the medias here in a minute. The time of backwash must equal at least 2 bed volumes of water for that tank. Okay, in a 1 cubic foot tank, that's approximately 14 and a half gallons of water. You can do some calculations on this, but rough calculations, for every cubic foot, you need a 2 cubic feet of water to go through it, which is approximately 7.5 gallons. Bed volume is the water contained in the tank in the media loaded portion. So the water from the media down to the bottom of the tank. Freeboard, and this is critical to a performance of a filter, the proper freeboard. Too much, we don't get the dirt out of the tank. Too little, we flush the media out of the tank. Freeboard is the space above the media required to keep the media in the tank, but yet allow for proper backwash. If not, you want to use a distributor screen or a water diffuser to retain that resin. But if you don't have enough room for that bed expansion by the media's OEM requirements, you aren't going to get a good backwash, and your media life and capacities will suffer, especially longer term. Bed lifts allows for dirt to be loosened and organics and things bound to the media itself to be scrubbed free by all these chaotic collisions. Think of a lotto machine. All the balls bouncing around. Every time a granule of activated carbon bumps into another, that force is knocking debris and scrubbing organics off the surface. So backwash cleans media for success and long life. And one of our one of the seminars I went to on cation exchange resins, OEM manufacturers of cation exchange resins say backwash is the most critical step to the regeneration process, because if you can't get the dirt and the grime off of the resin bead, you can't exchange it, and you'll start to lose capacity very, very quickly. So what's happening during that backwash? So the water comes down, you start to see the dirt lift off the bed and go out to waste, and it's going to run until it's clean. So how long do we need to backwash? Well, 2 bed volumes are the minimum amount of water to meet a clean media, to get a clean media out of the tank. Bed volume is equal to the amount of media in the tank, and we're discounting the space that the media takes up, okay? We understand that. This is a good approximation to do this. Why? Because a little excessive backwash is not a bad thing here. Okay? So 1 cubic foot is about 7.48 gallons, 7.5 gallons. 2 bed volumes minimum is going to be about 14 to 15 gallons of water minimum is required. The backwash flow rate must be done at the bed expansion recommendation of the media OEM. Backwash is a little more technical than we thought. We just thought we were running some water backwards to the filter to clean stuff up. It's critical to the life of your media. So what bed expansion is required? Typical cation resins, and always go back to spec sheets when dealing with a specific resin. If you understand what it is or know what it is in the tank, understand that, you want to go to an OEM spec sheet. But typically you're looking at a 50 to 75% bed expansion. Pick the median range of 60 to 62 to manage seasonal changes in water temperature. This is for a residential application. If you're dealing with high purity waters or things along those lines, you may need to manage this actively with control systems. So there are products out there in the market that can do that. And you can balance those things out. But for residential situations, you're probably going to pick the median and make sure you set it kind of for the bulk of the year. If I'm in Chicago, I'm probably not going to alter this setup in a residence. But if I'm in Texas, especially southern Texas or South Florida, where I have a softener, I'm going to be looking at changing my residential backwashing media filters and softeners everywhere I go because the water is warmer there. We'll get into why. Now, we're going through this bed lift to do a couple different things. One is to reclassify the beads or media and remove suspended solids from the top of the bed. The resin bed should be expanded at least 50% by backwashing for at least 5 minutes or until the backwash water is clear. This is a process in backwash. The turbidity level or dirt load of that water coming out should follow a bell curve. It should start off clear, ramp up, and get dirtier and dirtier to a peak, and then come back to clear again. You can sample this, once every minute in a backwash cycle. I do this with little plastic shot glasses so I can see whether or not I've got a good backwash. And that also lets me know if I'm capturing any broken particulate of resin beads as well. But I'll be able to see whether or not that unit is backwashing thoroughly enough for its installation. The above may not be necessary in the case of an upload regenerated softener, since backwash and brine injection are incorporated in the same step in some processes. I do encourage that you use a backwash even in your upflow just after the brining. We want to get that bed clean. So we've got to expand the media bed in order to clean it. So just like with everything else in softeners and filters, water is the driving force, pressure and flow behind what we're doing. The softener really or media filter hasn't done anything but tell the water which way to go. The water's doing all the work here. So this is taken from a OEM resin manufacturer's spec sheet. So when we think about temperature effects on water, what we're talking about is density. So if you think about have you ever heard the phrase, when things get warm, they expand, and when things get cold, they contract? Well, the same thing is happening at the molecular level with water. So if the water's warmer and looser and more spread out, we don't have as much power to lift the media above us. We're going to try to slip through and by a lot easier as it gets warmer. And then as it gets colder, the water is tighter and denser, and it has more ability to lift that bed and throw it up. So in cold waters, we have much better ability to backwash filters because of the thickness of the water. In warmer waters, we're going to have to backwash longer to get that media lifted up and scrubbed properly. So you can see here the chart based on water temperatures that for a bed expansion of 60% at 80 degrees, we're going to need a little over 5 GPM. But if we were, let's say, in northern Minnesota, where we have cold water temperatures all year round, you may be as low as a 3.5 GPM backwash flow control. And a lot of times we shoot for the middle of the curve at 60 because that's kind of a balance with groundwater, since most of the groundwater coming out is in the mid to upper 50s. If you're doing well, the well water, the 60-degree F line is probably a good, reasonable choice. But if you're doing processed waters, pay close attention to this. In Texas, some parts of Texas, the tap water ends up coming out of the tap above 80 degrees during the summer just because of the ambient temperatures. I even know people in Texas that will shut off their water heaters in the summer just because you don't really need it. So understand regional effects based on water temperature are going to impact your backwash. So if you're having issues where you're losing resin life or resin capacity, or your activating carbon filters aren't getting clean enough, take a look at your water temperatures. This may be a fundamental issue to your backwash. You need to adjust the time. I had to do this in my own softener at home, simply because the dirt load changed. My municipality went from doing iron pretreatment to stopping iron pretreatment. So I have a much greater dirt load in my softener than I did before. I had to add a couple minutes to it to get it clean again. I was starting to see some iron break through the bed coming out my taps at various faucets in the house. And this was just out of the blue. And this was simple change. 2 more minutes on my backwash, problem goes away. The other thing is you want to make sure your backwash or your drain line flow control matches the rate you've selected. So bare minimum, and here in northern Illinois where the groundwater is fairly cold, I'm going to want a bare minimum of a 4 GPM flow control. My unit has a 5. So it's really about tweaking this to the environment you're in. Water softeners are tools to manage water. And like any really good tool, it's adjustable. It can be tweaked to meet the circumstance. And that's what you've got here with backwash. So types of, get a question coming in here. To confirm, warm water temp allows for better lift but requires longer backwash time? No, just the opposite there. Warm water allows for a less lift. It's not as thick. If you want to think about it this way, just a kind of a crude analogy, you had a plunger. Cold water is a plunger with no holes in it. Warm water is a plunger with holes in it. So as you push up, water is going to go through and not have as much force, whereas the solid plunger is going to push everything up uniformly. So the reason you have a longer time with warm water is so you adequately lift that bed. It takes longer to get that bed to move and rise up in warm water, whereas in cold water, that lift happens readily and the chaos starts much quicker. So warm temperatures, longer backwash, because you need to do more scrubbing. So there are charts available, not only from OEM media manufacturers, but there are charts available for resources all over the place online. And you can see, based on tank diameter, the flow rate you're going to need and the backwash flow rate. This is the service flow rate, backwash flow rate. As the media gets heavier, the greater the backwash rate. Okay. Most water softeners and valves on the market, water softening media is very light compared to all these other medias. Very, very easy to adjust for softening media. Now, when you're dealing with heavier medias, you're really going to have to pay attention to your flow rates and your pressures involved as well to get these medias to lift. You've got 6.4 on sand is for a 6-inch tank, anthracite, 3 GPM, KDF 5.9, very heavy. Magnesium green sand 2.6, still a heavy media. Multimedia tanks 2.9. Why? Because we want those beds to classify correctly. We got to get that bottom layer to move as well. So issues that arise when backwash is not done properly. Debris coats the media, preventing function. You can't get ions to the resin bead. You can't exchange them. Loss of capacity due to this following, whether that is particulate or organic. Dirt load will break through to the surface water. So you'll get dirty water coming out of the tank. Eventually, you move the dirt all the way through the tank. You have increased potential for biological growth if this debris is organic in nature. Media beds will compact. Just saw a picture of this online this week in a group where someone had filled a 1 cubic foot tank completely full with green sand, and the unit had to be cut apart to be serviced and removed. No freeboard, no expansion, failed media, not doing the job we wanted to. Pressure drop in service water. Why? Because we're getting a filter cake built up on the bed that resists flow. We're just basically straining out more and more debris the tighter we get dirt loaded in a filter. Excessive wear and tear on valve. Remember, this is all particulate. And if we're leaving too much particulate in the inner workings of a valve, you're going to wear and tear on those pistons and seals and spacers over time if you're not backwashing long enough. Especially if that debris is sand or iron particulate, rust particles, you're going to have more of an effect there. Premature failures and leaks, clogged injectors. That's how I found my issue with my backwash is suddenly my injectors were clogged and I was getting hard water. What's going on? Check the actual backwash flow rate during the backwash. Make sure you're getting it. If you're not getting what it says on that drain line flow control, you need to do something about that. Maybe that's an excessive length of run. Maybe that's a restrictive fitting or tube, or maybe it's low pressure and flow, low dynamic pressure and flow, where you may be able to change that if you have a VFD pump. Or you may need to increase the size of that storage tank to get you through the backwash. Those sorts of things may have impact. Probably is more likely to due to an improperly recharged bladder in tanks. Increase backwash time to remove a heavy dirt load. If you're dealing with excessively dirty water, dirtier than usual, backwash longer. You know the water in your markets, manage the water in your markets. Make sure a well pump and tank system are sized to maintain pressure and flow for the system. You may have to go to the extreme of installing a pre-filter to manage that dirt load. To be honest with you, if I can save water and use a cheap pre-filter to keep that dirt load out of my softener and keep it doing what I want it to do, which is exchanging mineral content, I want to manage my dirt load with a cheap pre-filter. So it's one of those things, if you're dealing with a lot of iron or sand or colloidal particulates, install a pre-filter, protect that equipment and reserve it for the purpose it's supposed to be doing, which is ion exchange. Check water temperature and adjust backwash for temperature, especially if you're below the Mason-Dixon line. I kind of draw a line at the top of Tennessee where I start looking at backwash temperatures based on groundwater and seasonal temperature loads. So this will help eliminate nuisance service calls and increase customer satisfaction. Plus, backwashing issues are not easy to diagnose. Most of the time, this will show up as I've lost complete flow. You pop the head off the tank and you've got sludge in the top of the tank where it's just built up over time. We've got dirt coming through the unit at the taps. This is at a point where you can't just backwash the resin clean again, you really have to refill and start over. When you could have just had a good backwash setting at the start and not had this issue. If you're apt to think about that freeboard at the top of the tank as a waste, you would be incorrect. That space at the top of the tank is very, very tempting to use, but you don't want to use it. It's there for a purpose and design purpose. So you can fill a tank up to where you need to be in the tank, but don't overfill it. If you overfill it, you're going to end up backwashing excessive resin out to drain anyways, or causing issues or losing capacity over time because you can't get a good backwash. So just to let you know, we've created a new training request email box for both Mark and I to manage. Training.request@pentair.com is available for all your training requests, whether that's in-person product training or troubleshooting training, water quality, basics of treatment, opportunity training, valves, controls, filter cartridges, reverse osmosis systems. If you just want to talk applications and shop, we're available for that too. You just want to give us feedback. Let us know what you're experiencing with our products in the field, and we'll go ahead and put those in the right people's ears and document that as well. So if there are any questions, feel free to unmute yourself or use the chat feature, and we'll go ahead and answer those for you now. Are there any questions? With Fleck products, do you recommend zeolite over berm? That is going to depend on tank size, really. When it comes to berm, it's about, let's take a look at some of those medias to answer that question. Question was, with Fleck products, do you recommend zeolite over berm? Now, this is getting into a technical question on media, but having to use a OEM's term for zeolite coated resins, Catalog's light. Let's just take a look at this. 1.8 GPM backwash flow rate, okay? Berm is, where did you go? 2.2, okay? Now, in a residential valve situation, all our valves can handle this flow rate, okay? Now, but let's go up to a large 16-inch tank, 15.4 GPM versus 12.6. Now, if you've got a 10 gallon per minute backwash or 10-minute backwash, this is going to be 154 gallons. This is going to be 126. So there's implications for water here. There are reasons to use both zeolite and berm. And really that's going to get down into the nitty-gritty of the water chemistry at each location. So if you have success with either one of those products in your market, I don't see any reason not to use either one or prefer one over the other. Typically, the selection of media is going to be determined by the local water chemistry itself rather than the tank size. Now, if we're dealing with 3900s and 2900 installs where the valve may not have the backwash rate, because if you remember correctly, we've got to get that bed lift, and it's something that's going to be harder to get the larger the tank is with flow rate. So larger installations are going to have more problems with heavier medias with the 2900s and the 3900s. If you need higher backwash flow rates, the 2815 stainless steel valve has one of the highest backwash rates we have, and those will work on substantially larger tanks in a single tank application. If you need alternating, that's going to be something you can do with that size, but it's going to require an external valve to act as a standby that'll need to be programmed. So really, that's really a water chemistry specific question. Are there any more questions? Oh, no problem. Yeah, I see questions like that a lot. Berm and Catalogs, the oxidative medias for getting rid of iron, which one to choose. A lot of that is really going to be based on individual water chemistry. Same thing with arsenic. We get a lot of that, hey, look at my arsenic removal system. Well, what works here may not work over there is really what it comes down to. We're managing water chemistry, so let's understand the water chemistry we're trying to manage and then apply the right tools. And guess what? There's a lot of ways to skin a cat, too, in water treatment. That's part of what allows us to differentiate from our competitors. It allows us to establish what works best in a area. I did the same thing in my own business. I would only use certain filtration setups in certain markets simply because they worked better there or gave me the versatility as a service provider to service that customer better in that water environment. I never locked myself down to one media, this or that, simply because it didn't give me the full set of tools I need to treat the water quality. I've literally seen neighborhoods where house to house, street to street, well water quality is different depending on how far they went down, local geology and things like that, where I've literally seen water come out of people's wells black and others perfectly clear, some with lots of iron, all in the same neighborhood. Zeolite seems to solidify easier than berm, but as you said, it depends on water chemistry. Yeah, that really is going to depend upon water chemistry. And that's probably someplace, if you're seeing your berm solidify or your zeolite solidify, you may need to adjust the backwash duration or the frequency, okay? Because what's going on with that zeolite is we're using that magnesium oxide to keep the pH water level up as we precipitate out irons, iron and heavy metals out of the water by forming hydroxides, which causes the pH to drop inside the water. So you've got a ton of chemistry going on, and that first layer of zeolite or berm inside a bed, and because of the pore structure of zeolites, you may get some lattice structures that form through them and kind of hold the grains together. But that zeolite also gives you that fine particulate filtration you may want in doing the same thing depending on water chemistry. So if it's locking up on you, either increase the backwash time or lower the capacity. You're finding it frequently on 13-inch tanks and above. Yeah, that's one of the hard things about balancing out in a practical sense, in a residential applications for iron removal, is how much capacity can I get out of that tank? And a lot of that is guesswork. You guys need to experiment, find out what works. So if you're seeing 13-inch tanks and locking up with this media, you need to manipulate that backwash time or lower your capacity or increase the frequency in which you're backwashing. Because that's just physically breaking up that stuff at the top of the tank. Because we're literally making particulate inside a softener or inside a tank while we're using Catalogs medias. We're promoting higher pHs so that they form hydroxides with metals. Most metal hydroxides are insoluble in water. They drop out. They form stuff, particulate layers at the top of the tank. and over time they're compressed together, and they're still in an aqueous environment, so they'll still react with each other. Hydroxides can take on lots and lots of different forms, so you get a lot of transitional chemistries going on in that upper level of media, creating different crystal structures. We'll jump down a nerd rabbit hole there. That was awesome. But typically that is nothing more than you need to backwash more frequently or longer. Are there any more questions? And I would suggest, if you're having an issue with a specific media, the OEM media people are fantastic. They want to address issues with their product. You know, if it's a specific brand of media, reach out to them. They'll talk you through, you know, if you understand you have a well water test, you can show it to them. They'll walk you through exactly how to set up their product as well. Remember that at Pentair, we're making a valve and tanks. You guys are assembling the finished product. Go to the details about a specific product. They're very, very helpful. And quite often they will just, you know, dig in and walk you through it and teach you about their media so you can apply it better. Why it's in not only their interest, but yours as well, to make you better at using their product. Those were some great questions. Thank you very much. If there aren't any more questions, thank you very much for attending. And if you know anyone who would like to attend or could possibly use to view this presentation, it'll be offered again at 3 p.m. Central Standard Time. Thank you very much. Have a wonderful and uneventful rest of your day, and hopefully it's as profitable as it is uneventful.